All right, so 2.5 is on factoring trinomials with a leading coefficient of 1. So I didn't really like the way the book showed this, and so I like to do it with a box, and so we're going to do it a little bit different than the book. The steps to factor when we're factoring when a is 1 are always going to be the same, actually, to factor any trinomial. And remember, trinomial is 3 terms. We're always going to factor out a greatest common factor if possible. If not, we jump to step 2. So we'll multiply a times c. Remember that the general form of a trinomial would be ax squared plus bx plus c. So when I'm talking about multiplying a times c, I mean we're multiplying the number that's in the front times the number in the back. So a times c gives us a number. And then we're going to list all the factors of that product that add, well, of the product. And then we find the pair that adds or subtracts to give us the b value in the middle. And that pair that we find, we're going to call b1 and b2. And then we're going to do a box. And so when I talk about box method, we're doing the opposite of what we did with multiply. So before, we put our factors on the outside of parentheses. And now we're going to be putting the inside in. And instead of multiplying, we're going to be dividing out. And so the first term of ax squared goes in the first box. The last term goes in the last box. And then we're going to put the pair that we found that works as b1x and b2x. And then what happens is we're going to take out the greatest common factor of each row. So what's our greatest common factor? What's our greatest common factor? What's our greatest common factor of each column? And then what we get on the outside, here and here, those are the things that end up in these positions. So we've got, I guess that's kind of a weird arrow. So it goes into this one, okay? Order doesn't matter. So if you don't have all of that down, just pause the video for a minute and write it down. The next thing it talks about is if a polynomial is prime or can't be factored, what does that mean? And what that means is you can't find a pair, like your b1 and b2, you can't find a pair that adds or subtracts to give you b, and then it would be prime. So as we look at example 1, our first step is the same. So step 1 is, does it have a greatest common factor? And if it does, we take it out. In this case, especially today, none of them will have a greatest common factor. So we have a 1 here. So we're going to go 1 times 20, which is 20. We list our factors of 20, which are 1 and 20, 2 and 10, 4 and 5. And we're looking for the pair that either adds or subtracts to give us 9. So if we look at the first one, 1 and 20, it either adds to give me 21 or subtracts to give me 19. If I look at the second pair, 2 and 10 adds to give me 12 or subtracts to give me 8. And then 4 and 5 adds to give me 9, which is what I want, or subtracts to give me 1. So now we found a pair that works. So we draw our box. And like I said before, the first term goes in the first box. The last term, the 20, goes in the last box. And the pair that we picked, the pair that I circle, goes in the other 2 boxes. And the order doesn't matter. I could have done 5 here where the 4 is, and I could have done 4 down where the 5 is. And then we're taking out greatest common factor. So I'm looking to see what divides evenly into 1x squared and 4x. So just like in 2.3, we look for the smallest number, which is 1. Does 1 divide into 4 evenly? It does, so we write it down. Then we look to see if there's a letter in common. They both have an x. We write it down. The smallest exponent is 1, so we only take 1 out. We look at 5x and 20. We look for the smallest number. The smallest number is 5, and we ask ourselves, does 5 go into 20 evenly? It does, so we write it down. Then we go the other way. What goes into 1 and 5? Well, 1's your smaller number. Does it divide into 5? It does, so we write it down. They both have an x. Smallest power is a 1, so we only take 1 out. And then we look at 4x and 20. 4 is your smaller number. Does it go into 20? It does, so we write it down. And then we just like to do that double check to make sure we're good. We just do multiplication now. So 1x times 1x is 1x squared, so it checks off. 1x times 4 is 4x. 5 times 1x is 5x, and 5 times 4 is 20. So because everything checks off, then my answer is going to be x plus 4 and x plus 5. And I don't put the 1 in because the computer doesn't like it. So when you put your answer in the computer, it doesn't like it when you put a 1 in. It's not needed. When I look at example 2, it's the same thing. Normally I would do step 1, but step 1 is always, isn't needed for today. And so we're going to multiply 1 times 28, which is 28. Factors of 28 are 1 and 28, 2 and 14, 4 and 7. And notice that I go in order. I do that to make sure I catch everything because it makes it easier. So now we're looking for a pair that adds to give me negative 16. So 1 plus 28 is 29, doesn't work. 28 minus 1 is 27, doesn't work. 2 plus 14 is 16, that does work. 14 minus 2 is 12, doesn't work. 4 and 7 is 11, 7 and minus 4 is 3, so that doesn't work. So 2 and 14 is our best bet, and we need it to be a negative 16. So in order to get a negative 16 with 2 and 14, both of these have to be a negative. So negative 2 plus negative 14 gives you negative 16, so that checks out. And then negative 2 times negative 14 is positive 28, so that checks out. And then we do box. So we do the box, we put in our terms, so we've got y squared and 28, and then we have negative 2y and negative 14y. And then we take out our greatest common factor. So greatest common factor out is 1y. Greatest common factor out. And again, we're looking for the smallest number. So does negative 14 divide into 28 evenly? And it does, so we write it down. We do y squared and negative 14y, which is a y. And then negative 2y and 28. So negative 2 is your smaller number again. Does it divide into 28 evenly? It does, so we write it down. And then we can do our double check. So 1y times 1y is 1y squared. 1y and negative 2 is negative 2y. Negative 14 and 1y is negative 14y. And negative 14 times negative 2 is 28. So everything checks out. So then my answer is y minus 2 and y minus 14. As we look at example 3, the same idea. Again, we don't have a number in front. So we've got 1 times negative 16, which is negative 16. Factors are 1 and 16, 2 and 8, or 4 and 4. And just like before, I need a pair that's going to give me a 6 in the middle. So 1 and 16 is 17. 16 minus 1 is 15, so it doesn't work. 2 plus 8 is 10. 8 minus 2 is 6, so that might work. 4 plus 4 is 8. And then 4 minus 4 is 0. So in order to get a positive 6, I have to do 8 subtract 2 to get 6. So 8 subtract 2 gives me 6, so that checks out. And then is negative 2 times 8 negative 16? It is, so that checks out. So once that's the case, then we can draw our box. First term goes in the first box. Last term goes in the last box. The pair that we pick goes in the other two boxes. And the order, again, doesn't matter. And then we take out greatest common factor. So greatest common factor out is m. Greatest common factor out, again, 8 is your smaller number. It divides evenly into negative 16. So we write it out. And then we're going to go 1m squared and 8m. So again, 1m comes out. And when I look at negative 2 and negative 16, negative 2 is your smaller number and it goes into negative 16. So we take the negative 2 out. And again, we do our check. 1m times 1m is 1m squared. 1m times negative 2 is negative 2m. 8 times 1m is 8m. 8 times negative 2 is negative 16. Everything checks out, so your answer is m minus 2 and m plus 8. And again, I don't put the ones in just because your computer doesn't like it. Example 4, same idea. So there's really a 1 here. So 1 times negative 24 is negative 24. Our factors of negative 24 or just 24 are 1 and 24, 2 and 12, 3 and 8, or 4 and 6. And I'm looking for a pair that gives me negative 10 in the middle. So 1 and 24 is 25. 24 subtract 1 is 23. Didn't work. 2 plus 12 is 14, but 12 subtract 2 or 2 subtract 12 gives me 10. That might work. 3 and 8 is 11, or 8 subtract 3 is 5. 4 plus 6 is 10, which I want, and 6 minus 4 is 2. So a couple things you were looking for. In order to get negative 10, you'd have to have 2 subtract 12, or you'd have to have negative 4 and negative 6. And so as you look, 2 plus negative 12 is negative 10, and negative 4 plus negative 6 is still negative 10. So that checks out. But then you want to look at your multiplication. If I go 2 times negative 12, that gives me a negative 24, which checks out. Where if I went negative 4 times negative 6, I get a positive 24, and that doesn't check out. And so now I do my box. And same thing. First term goes in the first box. Last term goes in the last box. The pair that I picked, which was this one, goes into the other two boxes. And then we're going to take out greatest common factor. So greatest common factor out is 1p. Greatest common factor out, the negative 12 is your smaller number. Does it divide into negative 24 evenly? And it does, so we write it down. Going the other way, 1p and negative 12, we take a 1p out, and then 2p and negative 24. 2 is your smaller number. Does it divide into negative 24 evenly? It does, so we write it down, and then we check it. 1p times 1p is 1p squared. 1p times 2 is 2p. Negative 12 times p is negative 12p, and negative 12 times 2 is negative 24. So we just do distributive property, or we're just checking it as if we're multiplying. Everything checks out, so my answer is going to be p plus 2 and p minus 12. When I look at example 5, same thing. First step is always to multiply. So we're going to go 1 times negative 12, which is negative 12. Factors of negative 12 are 1 and 12, 2 and 6, 3 and 4. So as you look at it, we're trying to find a pair that gives me 8 in the middle. So 1 plus 12 is 13. Oh, I'm not sure why I'm circling that. Or 12 minus 1 is 11. 2 plus 6 is 8. Or 6 minus 2 is 4. So 2 plus 6 works because we're trying to get 8 in the middle. 3 plus 4 is 7. Or 4 minus 3 is 1. So our one that looks like it's going to work is 2 and 6. So 2 plus 6 gives me 8, which is good. But is 2 times 6 negative 12? It's not. And so because there's not a pair that works, this is an example of a prime. We probably don't need to do example 6. It will be the same idea. So that's what it's going to look like when it's prime. Just to give you a heads up, that can happen. It doesn't happen very often, but it can happen. So hopefully that's a good start on what we're going to do with factoring. Next time we'll talk about if there's a greatest common factor first.